Y'all, scientists just created the most detailed brain map ever, and they did it by making mice watch TV. Nah, for real, they recorded the brain activity of an area that's responsible for vision while having the mice literally watch movies and YouTube clips. Then they dissected the brain, took a really small piece of it, literally the size of a grain of sand, and then sliced them into 25,000 different layers and took pictures of each layer with an electron microscope. Finally, they sent that data to this other lab that took all those layers and combined them into this 3D structure. There are 200,000 brain cells in there, 75,000 of which are neurons, and over 500 million synapses, which are the connection points between neurons. Let's take a step back. That was a grain of sand worth of a mouse brain. Imagine how much it would take to map the whole human brain, which has 86 billion neurons and trillions of connections. Bruh, the size of the data set of just this project alone is equal to 22 hours of HD video content. 1 grain of sand. How are we gonna solve the human brain? I'm a brain scientist, I guess I'll stay employed for life, right? I'll tell you what other progress we're making in the lab though. Scientists like myself are using special tools to map different brain connections. There's a bunch of different ways to trace neural pathways, including using viruses, which I have a pretty detailed video about that I'm gonna drop in the comments, and genetically modifying the animals to make certain neural pathways light up. And then you can look at that under a microscope. And I'm actually using both of these for my PhD project, which studies the neural connections underlying chronic pain. The ultimate goal is to understand how the brain wires itself and then how these pathways differ under different neurological conditions like Alzheimer's and Parkinson's, or different psychiatric conditions like schizophrenia or depression. Think like more precise and targeted therapies that can help rewire the brain and help alleviate their symptoms. Another good example is brain-computer interfaces, which have already been developed to help paralyzed patients move around again or even speak through a computer. So then these brain-computer interfaces rely on all the things that scientists are discovering about brain circuits that underlie things like movement. Anyway, there's a lot of work cut out for us, but we already have the complete wiring diagram for worms and flies. Still working on mice, but they're not as detailed as this really intensely studied grain of sand worth of brain in this most recent study. So exciting regardless. Follow for more science news.